Okay, so we're going to look at metallic bonding for this question, and specifically how the structure and bonding of the metals affects the various properties that we have. This question is separated into 4 different parts. The first part is asking us to draw a nicely labeled diagram to show how this happens. And then the 3 questions that come later is asking us how the atoms are held together, whether or not that arrangement then allows us to have high or low boiling points, and then the standard question for metals is about whether or not they're good conductors of electricity. So what we'll do is we'll get straight into drawing the structure, and what we'll do is we'll draw a nice regular arrangement of solid particles. Okay, we'll draw 8, we'll do a 4x2 grid, and this structure, once we've kind of got it, allows us, as we're going along, to kind of explain each of the 3 subsequent questions as we're going along. We have a regular arrangement of positive metal ions in the center. Okay, key point being regular. Okay, so we'll label it up as we go along. We've got this regular arrangement of metal ions. Okay, of metal ions. Okay, within the center. And then what we have, obviously, as we know, is electrons around the outside. And we'll imagine they've just got one. Imagine it's a group 1 metal. They've all got one outer electron. Obviously, the number of electrons is fairly irrelevant, but they've got outer electrons. And the key thing for these ones, obviously in a metal, is that these are delocalized electrons. It's this delocalized nature which, while we're at it, allows us to explain why metals conduct electricity. So in answer to this question, they are obviously good conductors of electricity because we've got delocalized electrons. Standard answer for this type of thing. Delocalized electrons that can move through the structure. Okay, so moving through the structure, kind of second mark to the question, and the supplementary type of situation, carrying charge. Got to kind of explain nowadays what electricity kind of is in a chemical sense. So it's the delocalized electrons that can move through the structure, carrying the charge. So it kind of answers the final question while we were talking about delocalized electrons. So get back to the second question though, is how the atoms are held together in this arrangement, and they're held together because of strong electrostatic. This is the attraction between the positive nucleus and the negative electrons. Strong electrostatic attraction between positive nucleus and the negative electrons. Okay, and that's how the metal is held together. We have the delocalized negative electrons able to move around and attracted to the positive metal ions in the center. And then when we look at the final question that we've not answered yet, is whether or not this arrangement causes us to have high or low boiling points. And the key thing we've just said in the previous question is that we've got strong electrostatic attraction. That gives us high boiling points generally. And the reason being is because we've got strong bonds, as we've just said, and strong bonds need a lot of energy. Okay, need a lot of energy to break. Okay, so if you can set up the initial diagram properly and understand what's happening in metallic bonding, you can then go through the individual questions, explaining them as you go.